As we learned in chemistry class, chemical reaction occurs with the formation or cleavage of bonds between atoms. These chemical bonds form when atoms share or exchange electrons. The chemical reactivity can be controlled in several ways. Among them, the control of electronic property at the reaction site is generally employed. For example, electron-rich molecule prefers to react with a molecule that can readily accept electrons. Many atoms can form functional groups that either donate or withdraw electrons and control the electron density distribution of a molecule. These functional groups can vary the electronic property of the molecule to speed up the intended chemical reaction. Commonly referred to as inductive effect, the electron donating group pushes electrons to increase the electron density at the site where the reaction takes place. Conversely, electron withdrawing group removes electrons and reduces the electron density of the reaction site. In 1937, the American chemist Lewis P. Hammett quantified the electronic effect of functional groups in various types of organic reactions. More than 80 years later, Hammett's research is still widely used to design an efficient reaction or catalysis by modulating the electronic property of target molecules. However, this approach involves a frustrating and inefficient amount of tasks. Since each functional group can render only a specific inductive effect and sometimes, it may not be possible to synthesize target molecules which have desired functional groups due to a synthetic difficulty. These constraints have forced researchers to prepare numerous derivatives for a series of complicated reaction scenarios. Led by Professor BAIK Mu-Hyun, the Center for Catalytic Hydrocarbon Functionalizations within the Institute for Basic Science, IBS, the Department of Chemistry within the Korea Advanced Institute of Science and Technology, KAIST in Daejeon, South Korea, and Han Sang-woo, the Department of Chemistry. Employing a gold electrode, the researchers attached the target molecules onto the electrode. Just like functional groups generate diverse electronic effects, we wish to change the properties of the immobilized molecules using different voltages. The beauty of our discovery is that one electrode fits all reactions, as the single electrode can behave like multiple functional groups just with the switch of applied voltage, notes Professor Mu-Hyun Baik. The research team showed that the gold electrode can serve as a universal functional group to control the reactivity of a molecule, thus propelling or inhibiting the reaction just by switching the voltage applied to the electrode. In the base-catalyzed ester hydrolysis reaction, a representative organic reaction that Hammett had used to establish the conventional inductive effect 80 years ago, the application of plus voltage on the electrode decreased the electron density of the carbonyl carbon in the ester molecule. Thus, the reactivity of the ester molecule was significantly enhanced. Conversely, when voltage was applied, the reaction barely proceeded owing to the high electron density of the reaction site. They have also successfully controlled the reaction rate of the Suzuki-Miyaura cross-coupling reaction, a major catalytic method for forming carbon-carbon bonds. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.